In this video, I want to talk about what are called linear fractional transformations or linear fractional transforms. It turns out that these functions appear absolutely all over the place in complex analysis, so they're given a name. And of particular importance are what are called Mobius transformations. So I'll write this as a proposition. It turns out that this function f, okay, so f, where it's az plus b, over cz plus d. Here, a, b, c, and d are all complex numbers, naturally. But f has an inverse, or is a bijection. I can't spell. Has an inverse if and only if. So if and only if the quantity ad minus bc is not equal to 0. Okay, so linear algebra fans should that should remind you of something in linear algebra. But anyway, so this function has an inverse if and only if ad minus bc is not equal to 0. And then moreover, if that's the case, f inverse is going to be given by dz minus b over cz minus cz plus a. Okay, so this is the inverse. So you can check, and it's one of the homework exercises to verify that this actually is going to be an inverse under these conditions. And these are called, so if ad minus bc is not equal to 0, then this function f given by az plus b over cz plus d is called a Mobius transformation. So Mobius transformation. This is the same Mobius of Mobius strip form. So you've probably seen Mobius strips, but same Mobius. So this is called a Mobius transformation. Okay. Now, the last thing that I just want to call your attention to, and I've already alluded to this, is that this AD minus BC being non-zero should remind you about 2x2 matrices in linear algebra. So there's a connection here. So there's a connection between a 2x2 matrix A, B, C, D and the fractional linear transformation AZ plus B over CZ plus D. And of course, you'll remember that this matrix ABCD has an inverse exactly when AD minus BC is not equal to 0. So it has an inverse if and only if AD minus BC is not equal to 0. And moreover, the inverse is given by 1 over the determinant of A. So in this case, the determinant is AD minus BC. So since it's non-zero, we can divide by it. And what you do is you switch the role of A and D, and then you make the B and the C negative. And that's exactly the role of the inverse here. So if you notice, we switched the role of A and D, and then the B and the C terms we made negative. Okay, so there's something going on here, some sort of connection between Mobius transformations and 2x2 matrices. So to explore that, I'll point you towards exercise 3.10. Okay, so you can look at exercise 3.10 and make that connection there. So in the next video, we'll talk about all sorts of properties that Mobius transformations have.